Hello everyone. I got some mails regarding from some people, and they are asking me to prepare one slide, one presentation on type of protection techniques used in hazardous area. I have discussed in the last PPT that there are some protection techniques are there which are used to use that particular equipment in a hazardous area. So we will discuss all type of protection techniques used in hazardous area to make equipment safe and area hazardous free. So before starting the PPT, I will request everyone to subscribe my channel and hit the like button and subscribe button so that you get the intimation of new video as soon as I will upload on the channel. So let's start. So in the last presentation also I have discussed about type of protection. Most common applied types according to IEC 60079 standards are like below. Part 1, like you will read this IEC 60079-1, that is flame proof equipment. -1, that is flame proof equipment. -2, that is pressurization protection. -5 is quad encapsulation. -7 is increased safety. -11 intrinsically safety. For instrumentation guys, this is very important, and I will prepare a separate video on intrinsically safe, that how the energy which is going into the field is limited and sustained to have any hazardous impact. And -15 is not incentive. -18 in molded encapsulation. 28 is optical radiation. 31 is protection by enclosures. So we will go one by one. So yes, first is flame proof enclosure. This is 60079-1. So the basic design in the flame proof enclosure EXD is enclosure is strong enough to withstand internal explosion. Flame proof means all the flames which are inside the particular enclosure is not capable of going outside, so that it can impact the hazardous area. The design allows internal ignition sources like sparks and hot spots. So critical aspects for flame proof enclosure is enclosure strength, flame path based on joints, pressure piling, heat loss of built-in apparatus, and entry devices. Fine. So next, increased safety, EXE. This is denoted as EXE, and in this basic design is increased safety level for normally non-sparking apparatus. This design does not allow any unprotected sparking component inside. What is the difference between flame proof and increased safety? In this, there are no unprotected sparking components inside, and if any sparking components are there in flame proof, the design does not allow the sparks or limited hotspot to come outside the enclosure. This is the main difference. Hope you have understand. And the critical aspects in increased safety is creepage and clearances, enclosures, IP rating comes into the picture, and heat loss, wiring and terminations. Fine. And now comes the most important, intrinsically safe, EXI. Basic design and limitation of energy in the whole electrical circuit. This I will, if anyone asks, or I am thinking of preparing a separate video on this, that how the energy going into the field is limited. Energy is half C into U square is equal to capacity into voltage square, and energy inductivity into current square. Intrinsically safe circuits are normally supplied from safe area and basically limited the voltage by Zener diode and current by resistor. Take into account maximum cable length because of increasing C and L. So this is the typically design. This is the in right side you can see this is the control room equipment. Intrinsically safe barrier is there which limit the energy which is going into the hazardous area, and this is the intrinsically safe equipment installed in the hazardous area, and the energy being supplied to this is limited. It cannot generate a spark or something. Fine. The blue circuit shall being verified before commissioning as per IEC 60079 14. 14 is for EXI. Alright, modulated encapsulation EXM. Basic design is simple. Modular molding the electrical circuit. Examples are solenoid valves, printed circuit boards, PCB and solenoid valves is molding of the electrical circuit. You can see that in PCB also some printing electrical molding is there. So critical path thickness of the potting. Internal free volumes are limited. Aging of the potting material. Potting shall be non-hygroscopic. So yes, next non-incendive EXN for EPL-GC only. What is EPL? That is equipment protection layer. We have discussed in the last slide. So basic concept in EXN is consist of several subtypes of protection, in most cases being simplified version of existing type of protection. This the IEC standards for this is IEC 60079-5 EXNA non-arcing, NC enclosed construction, NR restricted breathing. So I will prepare a separate video if you are interested. I am just going for a brief introduction of all these things. Optical radiation EXOP. Basic design is safety by either limitation of radiation or protection of optical light. This is important, and this type of protection is divided in EXOP, inherent safe, protected, or OPSH with interlock. Okay, fiber optics loop monitoring, no return or stop. So this is the optical, to prevent the optical radiation cannot come outside of enclosure. So optical radiation EXOP is being used. Pressurized enclosure, this is very I mean useful in the hazardous area. Basic design is keep dangerous atmosphere outside by overpressure. You have to make pressurize this cabinet to prevent any hazardous thing to go inside this cabinet. Aspect, first a purging of 5 times the internal volume for EPL-GB, redundant guarding of the flow required, then compensation of leak losses plus power on. For EPL-GB, mandatory power off when pressure drops. Spark arrestor in the outlet, and in the venting side you need to install the spark arrestor also, so that in the vent, from the venting hole, spark should not get inside. And powder quartz filling, basic design is extinguish any ignition source in quartz filled source. So in this equipment, if the quartz are filled, so any spark is get generated that is consumed by the quartz filled. Example, mobile computer, electronics in quartz, keyboard or touch screen intrinsically safe controlled. Combination with intrinsically safety, X certificate and specific conditions of use. Protection by enclosure EXT for dust only. This is used for dust only. Basic design is minimum IP degree for dust tight enclosure depending on the dust group. A minimum IP rating of either IP5X or 6X. Critical aspect is IP5X and 6S rating depending on EPL and dust group. Heat dissipation to fill the maximum surface temperature indicating as. Okay, so marking of the equipment based on the applied types of protection, including their level of protection. These levels are level of protections are A, B, and C. This is safety level description. A is very high, B is high, and C is normal. So I have discussed in the equipment layer of equipment protection layer slide also in the last video. There you can see GA, GB, and GC. This is the same ABC. Fine. And how to read the marking, let's demonstrate an example. That like if you can see on the you can see here one marking is there. So EX means explosion protected, DB means flame proof, D with the level protection of B, this means not very high, it's high, and EB is increased safety with level protection of B. Fine. IA and GB square brackets associated approach intrinsic safety with protection of A. Overall application is because of the insert of maximum, the equipment protection level is GB. IB and S2 group I Roman B, Roman 2B additional including hydrogen. T5 is the maximum surface temperature is classified as 100. It's safe. The whole assembly has EPL of GB zone 1 and certified by responsible certification body is DK, and 13 is the year of issuance, and 0075 certificate number from DRKA. So this is about the complete video. Thank you everyone. I will again request to subscribe my channel so that you will get the video and intimation of any video very early. Goodbye.